Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to talk about game and simulation development. So, this presentation is mostly talking about what it takes to become a game developer, or really what skill sets we want to build as game developers, and the format of this course, and some ground rules. So why would we want to become a game developer? Well, there's a number of reasons. Maybe you want to work as an independent game developer. Maybe you want to actually work for a company that build games. But there's also other reasons. You will find that game technology is used in other industries. And even if you don't do something that returns money, it is a very good way to develop your programming skills and show off your skills. Also, a lot of new technologies show up in the game world and then get used in more commercial applications. So it's a way to prepare for new technologies in the future in what amounts to a very fun style of development. Independent games. If you want to become an independent game developer, the advantage of this pursuit is that you can build the crazy weird idea you always wanted to build. On occasion, you may actually strike it big. Minecraft, for example, is a game that has been very successful, developed by an independent game developer. No matter what happens, whether you strike it big or not, you will be an amazing programmer. And being an independent game developer may be a stepping stone to joining a AAA game studio. And the final advantage of being an independent game developer is you're the boss. You get to decide how your game will be developed. The disadvantage is because it's your crazy, weird idea, and often you have only yourself to govern this activity you're doing, you may find that no one may like your game because of its uniqueness. The odds are that while you may strike it big, most likely you probably won't. And most independent game developers don't get paid for their work. If you do want to strike it big, you're going to probably find out that most of that work will be being an entrepreneur, and you may not have as much time to be as creative as you want it to be if you're trying to be an independent game developer and sell your games. Probably the primary disadvantage of being an independent game developer is it takes a massive number of hours for very likely no return on investment. And another disadvantage is you're the boss. You have to make the decisions. You have to deal with all of the problems. Joining a AAA studio, one of the advantages is it's a job. You get paid for your hours. You'll work with an amazing group of programmers, artists, and writers. You'll most likely be at the leading edge of amazing products. And it's competitive and it motivates you to be the best. So if you succeed in getting a job with a AAA studio, it's very rewarding. The disadvantage is you may find out game development is not that dissimilar from any other programming job. You have to show up on time, you have to deliver results, and you will have a boss. It's probably not going to be your crazy, weird, awesome idea, but you might find that you can influence a part of a bigger idea. And everyone wants to be a game programmer, so prepare for competition to get those jobs. But even if you don't become an independent game developer or join a AAA studio, there's a lot of benefit from pursuing game technology. Game technology is creeping into other industries. Museums use it to enhance displays. In education, games are used to provide instruction in other more fun formats. In industrial training applications, being able to have people practice dangerous tasks, for example, driving forklifts, in a 3D virtual world before they actually get into the real system provides the capability of reducing risks. And data visualization, often we can communicate a lot more information if we can present it in a 3D model than if we just limit ourselves to 2D grids and graphs. In the military, game technology has been used to do things like fly out the air tasking order and show what your plan will look like in a 3D world. And finally, there's a concept of gamification where we use the motivating capabilities of games to make work more enjoyable and more motivating. So what is gamification? It's using the things that make games fun, addicting, and engaging, and applying them to work, customers, education and training, and even self-improvement apps. For example, exercise, personal development. Games are inherently complex, so if you can figure out how to program a complex game, you most likely can figure out how to program anything. Because of their complexity, make extensive use of your object-oriented skills, and in ways that are different than what you might generally find in an enterprise application system. So games are a great way to build your ability to build software, and in addition, because they require the use of multiple different skill areas, they're a way to get a team of friends who have different skill sets, artists, writers, and other programmers, and you can take them to a game jam and learn to code as a team. Games are inherently a great way to showcase your skills. You can use them to illustrate complex concepts. And imagine, for example, if you implemented an algorithm to simulate customer behavior, you could show the results of that algorithm in a table, which would be rather boring. Or you could create a 3D graphic simulation that shows the algorithm in action, and that will instantly convey your mastery of that algorithm. In the future, we probably can expect that much more will be done with 3D. There's only so much you can do to improve information density in a 2D and text environment. And we've probably met the limit of that already. At this point, the internet will probably change the style that we display text in, or the way websites look. However, with 3D, we can drastically change the way we present information. An example of this is Microsoft's HoloLens technology. Initially, these will cost about $3,000. They're not likely to be home gaming devices. Initially, they're most likely to be a business device, but they'll be using 3D modeling technology, and they'll need tools like Unity 3D to program the objects in that 3D environment. So let's talk about what you need to be able to do game and simulation development. First, we need the capability to do design. Then we need the ability to collaborate as a team. We need the ability to create 3D models. As a game developer, you will need to know how to program. In this course, it'll be C#. We'll also need to have some basic sound and graphic design capabilities with GIMP or Photoshop. Putting all these skills together, those are the skill sets that we'll need to become a game developer or game programmer. Now, for this course, we're not looking at becoming artists, but we do need to know some fundamental 3D modeling skills. And so we will build a simple we'll do some simple character animation so that we understand how models are created, how textures are applied to them, how they're rigged, and how animations are created. We also need to know how to use a game development framework. We're going to use Unity for this course, but there are many others. Which game framework you choose to use is really not that critical. They all have fairly common features, but the ability to dig through a complex programming framework and figure out how it works is really the skill set that we want to develop when it comes to programming games. We also need to learn how to work as a team, and this requires learning how to be a leader, how to be a follower, how to do planning, and how to use version control in order to make our applications. And we need to learn how to do research and teach ourselves new skill sets, because the game technology changes every day. What we learn today may not be completely relevant in the future. So game design. The first part of developing a game is designing the game. The game design you could think of as the rules of the game. In addition, some games are narrative in nature, and so they'll have a storyline. And if you have a narrative game, then you probably need someone like a writer to write a storyline that will govern the levels that will be in your game. We also need to define how objects in our game are going to behave. And all of this needs to be to feed a central concept for what our game is about and what kind of experience it will provide to our players. We also need to know collaboration, and we'll need to have brainstorming skills to be able to work as a team and constructively build ideas. Break those out into tasks, and then take those tasks and group them into iterations. For each of the tasks, define the tasks for each of the elements that we want to implement for each iteration, and then after everyone completes their task, merge all those changes in a version control system. We'll also need some graphic design skills. We will need to make textures for our 3D models. We'll need to know how to make some seamless textures for larger surfaces. We will need to use graphic design for UV maps that we map onto our 3D assets. And also, when we just build, we need to have some way of building some simple icons. We need to make 3D assets if we're going to make 3D games, and that consists of modeling, UV mapping, which involves texturing our model, rigging, which involves basically building a skeleton to define how our model moves, skinning it, which is associating our model's vertices with elements in the skeleton, and an animation, which means describing common movements that our model will make that we will have performed in the game. As a programmer, we will put a lot of emphasis on your programming skills. You'll need to know how to bring assets into and out of the game, how to initialize and create scenes, how to switch between scenes, how to create GUIs for the user to control game actions in the game, how to move and control game objects, respond to user input either through the keyboard, the mouse, and in this course, using external devices like the Mio armband or some EEG devices or the Kinect. We also want to learn how to trigger animations based on what objects are doing. We will look at some network communication capabilities and how to deploy our game. For sound, we will need to incorporate the sounds in the environment. Environmental sounds for the scene, dialogue perhaps that may be triggered by certain events in the game, and incorporating possibly some music. This course is going to it's going to be a fairly standard face-to-face course. We're going to have some theory which will be done through some PowerPoint presentations and some discussion. We will also define some workflows. Most of the course will emphasize demonstration. So while we will do a little bit of theory development, most of it will involve being at the keyboard and actually working through examples. And then once you learn some simple examples, you'll be expected as a student to prove that you've learned those skills by completing some programming assignments on your own. And then also you'll need to work with other members of your class to do some group assignments. And the goal is that after you go through this process in this course, you'll be able to do this on your own. You'll be able to make your own theories, you build your own workflows, create your own demos, perform your own art, and organize your own team. And so I highly encourage that during this course and after this course, if there are any game jams in your local area, you use that as an opportunity to prove to yourself that you've learned these skills. The way our assignments are kind of laid out are first the class demos. Those will primarily be done in class. And once you you learn the concept in the class demo, you'll be given an individual programming assignment, and you'll get one class demo per class. You'll get one assignment per week, and they're scoped so that the amount of work you have to do hopefully is reasonable for 1 week worth of work. Finally, your group assignment is really one assignment that you have to do over the course of the entire course. Your exercises will mostly come from the Unity in Action book. They will be started in class and might be completed in class, so they may not take any additional time. They'll be turned in via Visual Studio Online and Blackboard. Your programs will consist of multiple assignments that you get that usually come due after the demo is completed in class. And they're scoped for 1 week worth of effort. They'll typically involve using skills learned during the demo, and they'll extend them some way. So you may be asked to, for example, take a particle effect you learned in class and maybe make a smoke effect with it. You might be asked to take a 3D player controller and modify the way it follows the mouse, the way the view follows the mouse. So those will force you to figure things out on your own. You will not be shown exactly how to solve those problems. You'll have to do some research and really dig into how the framework functions work. They also will be turned in via Visual Studio Online and Blackboard. This is an advanced course, so you're already expected to know how to write professional-looking code, properly formatted and commented. You can use a more agile self-documenting approach if you wish. However, your code must still be clear. If I have to read it twice or I have to go back and forth between multiple files to understand what you're doing, I'm not going to consider adequately documented. So how you document is your choice. I'll also be looking at how consistently you're commenting and how consistently you write your code. You should have a style, and it should be easy to figure out what's going on. Your group project will be completed with a team, typically between 4 and 5 people. You're going to get one total assignment, but it's going to be done in multiple 2-week iterations. And you're going to be asked to provide a progress demo and an iteration plan brief every 2 weeks. What that will consist of is, if your program is runnable, showing how it can run, or at least showing maybe some of the assets that you've built in that 2-week period, and discussing and what objectives you're going to implement, or what user stories you're going to implement in the next iteration. So you will decide as a group what you're going to implement over time. The goal is to complete the whole project by the end of the course. So you have to do some planning to figure out how you're going to go from beginning to end over the course of this course. There's also 2 special assignments that must be completed within all the other assignments you do. One is you must develop one 3D character asset and one 3D architectural asset as part of your individual or group projects. So if you create those and they're supporting the group project, then you've met the requirement. If one or both of those need to be added into your individual project, you can do that. You can develop more than just one character asset and one architectural asset. That's up to you. The second special assignment will be to research and employ an external device as part of your individual game or group project. For this course, I will have an Arduino, Nero Sky, Epoch Insight, Mio Armband, and Kinect for you to use. You will not be able to use the Oculus to meet this requirement because it's just too easy with Unity to use the Oculus. It's basically one checkbox. We will run our programs in the Oculus, and we will design our individual game projects so that they work with the Oculus. and we'll discuss what the design considerations are for that, but we don't need to incorporate it the way we would some of the other assets with their SDKs. If you have another device that you would rather use and you have access to it, you may use that. In fact, I highly encourage that. Just discuss it with me and tell me which one you might want to use. One of the things you'll see in this course that I've developed for it are workflows. One of the concepts that we want to implement in this course is teaching students to be autodidactic, basically the ability to learn on your own. To learn to ride a bike, you need to remove the training wheels at some point. And to become a programmer, you must be able to learn new things on your own without an instructor. So my job is primarily as an instructor is to make myself irrelevant. To help with that, what I've done is I've defined what the skills that we used in terms of workflows. And they're basically documents, Word documents, that just describe step by step how you do some common things. They're not all-encompassing tutorials that teach any one particular way of, or teach in depth how to do something. They're really meant to be kind of step by step reminders of skills you already know how to do. But often as we learn a series of skills, we tend to forget them. So having some workflows that we can kind of look up and serve as reminders of how we do common things can be useful. I will be providing you some workflows during the demos. You're encouraged to keep them, modify them, adapt them, share them with your friends and fellow classmates and with me. So if you find a really cool way to do things and you do a little write-up on it in a Word document, doesn't have to be too complex, doesn't even have to have all these pictures in it. I may enhance your workflow later on to make it better, but as this will help us as a group learn from each other. And so you will hopefully learn from your fellow classmates, and they will learn from things that you discover. And this course will become better as we build up a bigger library of workflows. So the way I build my workflows is I define what what skill or thing I want to do. I then break that down into steps, and then I research how do I do each of those steps. In this rigging and animation one, the goal was basically how do I create a skeleton and how do I then make an animation and save it. So that was my definition, and going through the books that we're using for this course and other websites, I kind of defined the basic a basic workflow for doing that. It doesn't have all the variations on it, but it just documents the basic way of getting that task done. And then after I write it down, I then try that workflow out with another project. And as I use it, I make modifications and refine them. Because this is a group project type of course, we need some ground rules on how we treat each other. The first and top level rule is be excellent to each other, which basically means treat others with respect. Try not to interrupt others when they're speaking, but if you're speaking, try not to monopolize class time. Give everyone else a chance to get some time to speak. Also, respect other people's cultures, their background, and their differences. Better yet, your real goal should be to take advantage of your team's diversity to make a better product. Some research is coming out now that's showing that teams that are more diverse tend to make better decisions. But to make that work, you need to learn how to use that diversity. And often that means making people in your team comfortable with expressing their real perspectives and views, and making a safe space for people to be different. One of the things I ask in order to enhance that is no name-calling, verbal or written abuse, no ridicule, be polite, use common sense, and if there are any issues, bring them to me and let's see if we can resolve them. You'll be creating your own games, and however, the content you create for this course needs to reflect well on CNM and yourself as a student and programmer. If you want to if you are making if you wish to make a more controversial subject game, I recommend saving that for a project outside of the course. All our content must comply with CNM's rules and student code of conduct that's at the URL listed there. So think of this as a way of picking this course. The real purpose is to create portfolio items that would be good for any job you might get in the future. And it's not so critical that this be a game on the that is extremely edgy or pushing the bounds of culture. What you really want to create is something that proves the skills that you are going to develop during the course. So we talked about gamification, and one way to demonstrate gamification is to actually use it in our course. This course will be gamified, and what that means is that there will be some additional opportunities, optional opportunities that you can engage in order to increase your grade in this course. And I recognize that not everyone will have the time to do these extra things, but if you can, this is a fun way, hopefully, to derive some benefit from that additional work. And I will be assigning or awarding 1 to 5 game points for things like the following. If you go over and above on a game, adding more features than required, then that will probably gain you 1 to 5 game points per really awesome feature that you add, or even just interesting, kind of neat features that you add. My goal is really to kind of reward any additional work. Doing a presentation at the Albuquerque Game Developers Guild is an automatic 5 points. They meet every Tuesday, 6:30 at various locations. I will give more information about where they're meeting each week. But if they are a place where game developers demonstrate their games and get feedback from other game developers. If you present your game at the guild, then that's an automatic 5 points. Incorporating a feature not trained in class, that can be 1 to 5 points. Teaching me something new, I will award you additional points. Improving an existing workflow that I have published, or even more for submitting a brand new workflow, which kind of goes hand in hand in teaching me something new possibly, or at least documenting something I haven't documented yet. And there might be other things that I award points to that we figure out as we go along. The benefit to participating in this is whoever gets the most game points at the end of the semester will get plus 10% to their overall course grade. So their grade will go up at least 1 letter grade. If you're in the top half, you'll get plus 5% to your overall grade. And everyone who earns at least 5 points will at least get 10% added to 1 assignment. So this is what we went over today. If you have any questions, please let me know. Thank you.